Howdy. So this is the last video in our series on FunChem 1 labs. This is on the last lab on making solutions. And so this lab we typically do together, but it's based off the use of a volumetric um, flask. And so the key is that word volumetric means it has exactly one line. So the way these flasks work is we'd get the mass of the flask while it was empty. Then we'd add in our solute, whatever we're going to dissolve, and we'll add in a little bit of solvent to about the point they show here. So you can swirl it around and get it completely dissolved. And then you'd add in enough uh, solvent to get exactly the bottom of that meniscus on that line. If you overshoot it, you can't just take any out. You have to start all over. All right. So because this involves a little bit of practice to get it right, or a little bit of cheating, we usually go ahead and work these together anyway. All right. So this is volumetric flask. They've got green just so that we can see the difference. So two different parts to this. Part A, we'll be using acetone. So we measure it out about 10 milliliters in a graduated cylinder, and then we pour it in. And what's important is how much we actually get in, not how much we start with. And so I've got some example data that I'll be working through some of these problems with. And then the second part, B, the solute will be sodium chloride, and both of these will be using water. And so I've got some example data there. But I want to start with some of these terms that we'll be using, and we will see a lot of these show up in chapter 6. So we're going to start off with the most common, molarity. That's this capital M. Molarity is moles of solute over liters of solution. Now, I've already jumped ahead here. So a solution has two parts. It has the solute, what's being dissolved, and the solvent, what's doing the dissolving. All right. Now the solvent will be the one that's in greater amounts. Whichever one's in more, you have more of. All right. Now you have to be careful. The volumes are not additive. This is actually usually the lab that I demonstrate that to you. But if I take acetone and I take water, if I took 5 milliliters of each one, it would not add up to 10. All right. But if I took 5 milliliters of water and 5 milliliters of water and mix them together, there I do get 10. All right. But we can add up the mass. And so you always have to be careful when they give you the mass. Are they giving you the solute, the solvent, or the total solution? And if you know two, you can find the third. All right. So you always want to be careful of what the equation's asking for and which one they're giving you. So if you're looking for words like dissolved in, all right, or dissolves. Those are our keys. So if something is dissolved in, what's being dissolved is the solute. What's doing the dissolving is the solvent. The total thing is the solution. So molarity, mole of solute over liters of solution. What we're interested in over the total thing. All right. So the next one we're going to do is actually a weird one, and it's molality. Molality. All right. And it's going to be moles of solute over kilograms of solvent. It's the only one that doesn't have the total solution on the bottom. It's just got solvent. All right. And it's used in industry quite a bit. All right. The next ones I want to worry about then. So let's look at the percent by volume, or percent mass over volume. Both of those are abbreviations for the same thing. All right, and it's going to be grams of our solute over milliliters of total solution. And because it has percent in the name, we multiply it by 100. Okay. Now, this is confusing because we say percent by volume a lot of times because it has volume on the bottom. Uh, but it's not volume over volume because those are not additive. So this is used a lot, but it's also heavily confused with density, which we talked about in chapter 1, which had similar kind of units. So the units for this percent one should end up in percent. You just ignore the fact that grams and milliliters don't cancel out. But density is going to be grams of solution over milliliters of solution. Grams of the total. And it doesn't have this times 100. Alright, so we said mass over volume, but it was mass of the whole thing. Alright, so we got a pretty good start there. Let's worry about then the other percent by mass, or it's written percent M over M. Alright, these are grams of solute over grams of solution. And again, it has percent in it, so it has times 100. Alright, that's easy enough. But sometimes it's not scary enough, or the numbers are too small. And so we have some others that are related to this. And so a percent, I'll remind you, is some number out of 100. So the next one we'll look at is PPT, and it's part per thousand. And it's grams of solute over grams of solution times 10 to the third. In other words, 1,000. So it's some part over 1,000. Okay. The next one we would worry about is ppm. It'll be the same thing, grams of solute over grams of solution times 1,000,000. Or x over 1,000,000 is what it would mean. Then we have ppb. You can probably guess what it is. It's the same thing times 1,000,000,000. So it takes a real small percent, but it makes it into a much bigger number. So if you see something that, even if it said 5 ppb, it's actually a very small percentage. All right, but even on some things, that can be a dangerous amount. So percents we use for a lot of times for our maybe our sugar in our food or the caffeine in the food. PPT we might use for something that was poisonous in our food. ppm is quite often used for something poisonous in our drinking water. But ppb is usually used for something measuring the amount of something maybe poisonous in our air, the air that we breathe. All right. Now these, I pick on poisonous just to make it scary, but we use them for all kinds of other things as well. All right. It doesn't have to just be poisonous. All right. So these are our main set of calculations that we'll be doing. So let's run through some of these and look at this pre-lab. I'll give you some data, and then but I'll also be doing some example ones, and I've got some example data here already. So when I flip this open, first thing it says, mine says, give the definition of the following measurements. Yeah, you just write the formulas. Okay, that's easy enough. Then it says we've got an interesting question here. 2.065 grams CaCl2 dissolved in enough water to give 1550.0 milliliters of solution. And A, it asks for the molarity. A, molarity. Alright. Now, in all of these, what you really want to do is figure out, get it out of this mess, right? What did they give you? What did they want? So what they gave me 2.065 grams of CaCl2. and they mentioned 1550.0 milliliters. What is it they want? They want capital M, molarity. All right, I need to figure out these. Are they talking about solute or solvent or solution? And that's the key to these questions. So this grams of CaCl2, when I see this dissolved in, that's what's being dissolved. That's my solute. I'm going to go ahead and label it. And then this 15.50, it's either solvent or it's total solution, and they told me it was solution. So they didn't tell me how much water we had. They just told me that this is my solution. So I'm ready then for molarity here. Capital M is moles of solute over liters of solution. Alright, so I need to take my moles, 2.065 grams, and I'm going to have to go from grams to moles. And I'll use the molar mass for that. So reviewing that real quick, calcium, I'm going to find it on the periodic table, 40.08 plus 2 times chlorine, which is 35.45. Where did that 2 come from? That came from the fact that CaCl2 came from my equation. Alright, so we'll plug that in here. I got 110.98. And which gives me 0.01861 moles. That's not my answer yet because I have to divide that. I'm going to take that and plug it in and divide it by liters. Now, how many liters do I have? Well, I'm going to take the 1550 and convert that over. So I'm going to take my 1550 milliliters. 1 milliliter is 10 to the minus third liters. And so that'll be 1.550 liters. And now I can take my previous answer, divide that by 1.55, and I get my molarity was 0.012, and they started with 4 sig figs, so 4 sig figs is actually 0 there, and that's moles. There's my answer to part A. Ooh, a lot of stuff going on. We started with what I wanted to plug in, got everything in the right units, and then plugged it in. Alright? Ooh, okay, so part B, it says, hey, here's the mass of the solution, and it says the mass of the solution is 1552.1 grams, and that's solution. And then it wants to know what is the density of this solution. Alright, so I'm going to get rid of some of my previous work. And the density, we said it before, was the mass of the solution, 15 divided by the milliliters of solution, 1550.0. I'll get units in grams per milliliter. Around 1.001. Alright, easy enough. Then it asked me to find the ppm. The ppm, grams of solute over grams of solution. They gave that to me over here in B, right? And then times 10 to the 6. So 2.065 divided by 1550.0. Now, here's the problem. Usually we put the E, but we want this times 10 to the 6 out to the front. So you need to either put the times and no parentheses, or you can hit enter and then you say times E positive 6. No 10E. It's just E6. Alright? Good. And so you'll get a big number, and the units for ppm is ppm. Just like the units for percent is percent. Alright. So let's do this lab. It's got an A and a B. Lots of stuff going on. So we did all this reaction with acetone. So starting off, A with acetone, which is C3H6O. That's acetone. And so it said the flask was 34.512 grams. So I'm looking at numbers over here. And the flask plus acetone. So if I want the acetone, so let's start with the acetone. And I'm just going to do some subtraction here. 43.416 minus 34.512. And that gives me 8.904 grams of acetone. Okay. Then I added enough water, and so to fill up to the line. So we added enough water to get up to this line, and we measured the mass, and it was 92.425. So 92.425, and if I subtract out the flask minus 34.512, I get the mass of the solution. So the solution, which has my acetone and my water, is 57.913 grams. Okay, and then I'm going to take, it also says, hey, what was the volume of the solution? So the volume of the solution was 50.0 milliliters. Now, it depends on which volumetric flask you use. The one we use was 50 milliliters. How careful you are doing it, and the temperature, and how carefully they made this determine how many sig figs you can get there. We'll just go with the 50.0. Then it asks for the mass of the solution. I already got that. It asks for the mass of the water. The mass of the water. Now to get that, I'm going to do to the numbers what I do to the words. So I have the acetone plus water plus the flask, and I just want the water, but I also have that flask and the acetone, so if I can subtract those two out, I'd get just the water. So I'm going to take the one that had the total here, which was 92.425, and subtract out my flask and the acetone, which is 43.416. And the water we used was 49.009 grams. Okay, so there's my answer. I can already tell this example they overfilled it, but you know, whatever, it happens. They cheated a little bit, but okay, we'll run with it. So I have the mass of the solution, I have the mass of my water, then it asks me for molarity, percent mass over mass, percent by mass. It says percent by volume, percent mass over volume, and then density. So we'll do all those calculations. Book out of the way. Alright, now the hardest part for this is to figure out what's the solvent, what's the solution, what's the total going on. So this is solution. Acetone is my solute. The water is my solvent, if I need that. Be careful on these units. This is mass. And milliliters is telling me volume. Alright? I don't have the volume of solution or the volume of the solute, but we don't really need those. Alright, so molarity. Molarity then is moles over liters. It's moles of solute over liters solution. Alright, I need to take my 8.094 grams of acetone, C3H6O, and convert that to moles. 1 mole C3H6O. Let's see, that'd be 3 times 12.01 plus 6 times 1.008 plus 16. 36. Oh no, too much math. $58.078 grams. Now that'll tell me how many moles. So 8.094 divided by a second answer. This is 0.13936 moles. Now, how many liters did I have? Well, I have milliliters. And I'm going to go ahead and convert that over to liters. And I get 2.787 moles. Molarity. Let's see. Sig figs. Volume is my limiting factor here. Should have had another sig fig there. So that would have been 2.79 molarity. Okay. So I had to take it to moles, and then I had to take milliliters to liters, and I can plug it right. Not a problem. Then it asked me percent mass by mass. Percent mass by mass. We need to have grams of solute over grams of solution times 100. Alright, so grams of solute was my acetone, 8.904, divided by my grams of solution, which was 57.913. And then multiply that by 100, and I get 15.37%. Okay, percent mass over volume is grams of solute over milliliters of solution times 100. Now they're probably going to be pretty close here. Let's see, 8.904 divided by milliliter solution was 50.0 times 100. 8.904 times 2 be 17.81%. Okay, then density. Let's see if I adjust that room for this density. Grams over milliliters here, but it's going to be grams of solution, 57.913 grams over milliliters of solution, which was 50.0 milliliters. 57.913 divided by 50. 1.16 grams per milliliter. Notice I did multiply it by 100. So 1.16 grams over milliliters. That would be part A done. Okay, no problem. I'll go ahead and work part B too. So there's part A done as an example. When I switch over here and I do part B, my data, I had the empty flask was 63.421, so I'm looking at my data here, 63.421 for my empty flask. The flask plus the salt was 66.022. So how much salt did I have? So I'm going to take this 66.022 and subtract my empty flask, which was 63.421, and I had 2.601 grams of salt, NaCl. Alright, then I had the flask. I added enough water to get to it dissolve, and then I added enough to get it up to the line, and that was 116, and that was the flask, the salt, and the water. So 116.213, and if I subtract out the flask, it'll be 63.421, and that'll be 52.792 grams of NaCl plus water. Now if I just wanted to know the water, I would take the 116.213 minus 66.022, and that'd give me just the water, which was 50.191 grams of water. Alright, we had 100.0 milliliters of solution. Let's see, and then it asked me for the molarity, percent, mass over mass, ppm, and density. Everything else we already got it. Alright, so molarity, again, you're going to have to go grams over to moles. So let's show our work. This is alright, so I've started with my subtraction and then the givens. Alright, so molarity, wait a minute, this is my solute. This was my salt plus my water. That's my solution mass. This was a solvent. And did it ask molarity or did it ask molarity? Let me get a little check. Oh, it says molarity. Okay. On the previous one, it also said molarity. Okay. They used to say molarity. Alright. So, okay, that's easy enough. This is my solution, and it's the volume. Alright. So, okay. Here I'm going to take my 2.601 grams, and we're going to go from grams to moles, and this will be Na plus Cl, and it's roughly 58. 22.99 plus 35.45. 22.99 plus 35.45. 58.44. 0.601 divided by that would be 0.0445 moles. Now I'm going to take this and divide that by 0.1 liters. I'm taking my 100 milliliters. 1 milliliter is 10 to the minus third liter. Make my units cancel out. 1 milliliter on the bottom is 10 to the minus third liters. Alright, so taking this, dividing by 0.1, which is the same as multiplying it by 10, I got 0.445 moles per liter. Capital M. Alright, percent mass over mass, grams of solute, which is 2.601 grams, over grams of solution, which was 52.792 grams, It says times 100. 2.601 divided by 52.792. Now, what I'm going to do is I've got that typed in, and I'm going to hit enter. All right, and then I'm going to say times 100. And so that's going to give me my answer here, which is 4.9. We had 4 sig figs there, 927%. Okay, then the ppm, since it's the same first part, I'm going to go back up to that answer, use it, 0.049, and I'm going to multiply that by second E6, so I don't have to retype it in, and this would be 49268.8. Should be a big number, all right? And so then I'm going to set that equal to 4 sig figs, so 4927, and I need a 0, ppm. Notice no decimal. I want that 0 to be significant. You can show this same work down here times 10 to the 6. That's fine. The density, then the mass of the solution, 52.792, divided by the volume of the solution, which is 100 milliliters, and that's going to be 0.52792 total. 100.04 sig figs, 79 grams per milliliter. Whew. All right, so these numbers don't make much sense in terms of if somebody had worked this out probably correctly, I guess would be what I would say. So they probably cut some corners here. Maybe they overfilled it. Maybe they spilt a bunch of salt. Usually it's a problem of when they were shaking it, they spilt it, but most of the time it's just reading and they overfilled, added too much solvent. So I care about you getting the correct answers, and so I'll give you a new set of data, and you're gonna do the same kind of calculations, actually the exact same calculations. So you've got some to refer to, and it's great practice. This is wonderful practice for Chapter 6. You're gonna expect that on your third exam. All right, so we'll catch you on the next one.